Okay, using rectangles for distributive property. As I said, we're going to start kind of basic, and then we're going to build upon it. So example number 1. So next to example number 1, you're going to put 3 times 4e plus 5. So 3 times 4e plus 5. So what we're going to do here, we're going to use this area model to distribute 3 times 4e plus 5. Now, I know you guys can all take 3 times 4e plus 5 and distribute it and be done, and it's quick, simple, and over with. But I want us to use an area model because we're going to build upon it. We're going to start working with more numbers here shortly. So in our opener, you guys told me that the number on the outside of the parentheses is going to represent the what?
Height.
The height. So what's my height of these rectangles?
3.
The 3. So this is going to represent my height. Okay, then what's the 4e plus 5 going to represent? The length. Okay, now, how many terms are there here?
2.
2. How many lengths do I have?
2.
Which one do you think I'm going to put first?
4e.
So keep them in order. So you're going to bring that 4e straight to the first length of my rectangle. And then what's the second length of my rectangle?
5.
5. Okay, now, we're going to go ahead and find the area of each rectangle, and then that should be our final answer. So how do I find the area of the first rectangle, Logan? So area equals what? I'll use area equals height times length. So what's my height?
3.
And what's my length?
40.
And what does that equal?
12.
Okay. Go ahead and find the area of the second rectangle as well, Jenna.
Do 5 times 3.
Always do your height. Now, you're not wrong. You can interchange them, but for the premise of our lesson, always do your height first.
3 times 5.
Okay, what's that equal? 15. Now, we want to know the total area. So can you combine 12e plus 15?
No.
No. So it's just going to equal what?
It equals
12e.
Plus 15.
Yeah, plus 15. We're going to leave it just like that. So where I wrote my answer up to the right of my distributive property, that's where I'd like to see your answers written, your final answer written.
I just put it at the bottom.
Okay, from here on out, where do I want to see it? Because you guys know I'm picky, right? I think Riley just said, mm-hmm. What do you think your toughest class this semester is going to be?
Bio.
This? Bio? What else?
Bio.
Bio's not that hard.
You have trim.
No, I have this.
I had stat classes.
You had,
What's her name? She's like.
Smith, you had, are you out now?
What?
Did you go to Shram?
Yeah.
Have you always been to Shram?
No, I didn't today.
Oh, so you got put out for biology? What? Make sure I need to show that. That's awesome. Congratulations. Okay, distributive property. Example number 2. You're going to use 4f times 3f minus 5. Now, in all honesty, can you use a negative number to show the length of something?
No.
No. But just for our models, we're going to go ahead and use it. Okay, so what's the height of this rectangle? How do I label this area model? So when I say area model, this is what I'm referring to. So how do I label the area model?
4F.
It's my,
The first box.
which is my height, okay? And then,
3F on the first line.
okay? And then my second length,
5.
negative 5.
Oops.
Yeah, take that negative with it. Okay. So what's the area of my first rectangle? How do I find it, Hannah?
What?
Aww.
4 times 4f times 3f.
Good job. Which equals?
46. It's been a while.
I know, right?
8.
How about 12?
12.
F to the what? F squared. Remember, because we have f to the first, And then when we multiply variables that have the same exponent, you add the exponents together. Okay? What about the area of the second rectangle, Riley?
A equals 4F times 20
4f times what?
or 5.
What type of 5?
Negative.
Did you say negative 5?
Oh, I didn't see the
Okay. And what does that equal?
negative 20.
Negative 20 what? F. Okay. Can you combine these terms?
Nope.
But they have the same variable.
Nope.
Why? But they have the same variable. I don't understand.
They don't have the same exponent.
They don't have the same exponents. So in order to combine them, they not only have to have the same variable, but they also have the same powers. So I'm going to come up to the right and write my final answer. So my final answer is going to look like what? 12f squared
20.
minus 20f. Good. And that's how I expect to see your answers written.
I put A equals.
Miss Lidekin, are you going to make this harder? Yes. I promise.
I put A
We will build upon this lesson, and they will get more challenging for you, okay?
I put A equals 20.
But as Hannah said, it's been a long time, so I didn't want to overstimulate us too much today. So we're going to just put our answers right up to the right up here. You don't have to fix it now, just from here on out, okay? Okay, any questions on the first two examples? Let's keep going then. All right, example number 3. What's different about this example?
Height.
Well, it could. What's different about this example compared to your previous two examples?
It doesn't have a height.
It does have a height.
Well, maybe the left side is the height, while the right side.
How many heights does it have this time?
2 more.
2 heights. It still has 2 lengths, right? So what do you think my height will be?
2G plus 1.
Yeah, so your heights will always come first. So area equals height times length. So your height will always come first. So the first number or set of numbers is always going to be your height, okay? So that's always going to be your height. So what's the height? And they're going to go straight in order. So what's my first height going to be?
2G.
2G. And then what's my other height going to be?
1.
Okay. Then the second group of numbers is going, if you can't see Danny and you want to move over because I keep standing there, let me know. And the second group of numbers is going to represent my lengths. So what's my first length?
3,
And my second length? 4. So I'm just using an area model to distribute. Now, last semester, did you guys learn how to multiply this together? Yeah, we know how to distribute this. It ended up being a lot of work, didn't it? Because we had to take the 2G times the 3G. Then we had to take the 2G times the... Then I had to take the 1 times the... And then I had to take the 1 times the 4, and then I had to combine like terms. That's kind of what we're doing, but we're just breaking it down. We're just using an area model to kind of give us more of a visual to break it down. So what I'm going to have to do is find the area of each individual rectangle and then find the total area. So basically, I'm multiplying these two binomials together using an area model. Why did I say it's a binomial? A binomial times a binomial. What makes that a binomial?
The G's.
Not the G's. A binomial is a polynomial, and I know it's a binomial, which means 2 because of...
Because the 2 G's, so it'd be...
Just look at this one, because there's 2 what? 2 terms. So 2 terms times 2 terms. That's okay. I know, it's been a while. Okay, so let's go ahead and find the area of our first rectangle. Jenna, how do I find that first area?
2 multiply 2 times
How about 2G?
2G, 3G.
Okay, so I took my height times length and got
6G
6G.
squared.
Very good. Okay. Logan? Which area do you want to find next? Top right, bottom left, bottom right. You can pick whichever one.
Top right.
Okay, so what's your height? So we're always going to do our height times length. So what's the height of this rectangle here? So you're looking at the height of this rectangle here, right? So what's the height of this rectangle? okay, times the length, which is 4. And what does that equal? 8G. All right, moving right along. Ben, find the area of my bottom left rectangle, please.
Area time equals 1 times 3G.
And what does that equal?
3G.
What? Good. Okay. And let's look at the area of my bottom right. Danny?
It would be A equals 1 times 4. Not be 4.
And it's just 4. Good. Okay. So when we go to combine these terms, because I want to find the total area, do I have any like terms there?
Yep.
What are they?
8G, 3G.
So I have the like terms of 8G and 3G. Now, my terms have to be in a specific order, the order that we learned last semester. It has to be in ABC order, and it also has to start with the variable with the what exponent? Highest exponent. The highest power goes first. So what's that going to be?
6G, carrot top 2.
Okay, so I'm going to put 6G squared, or carrot top 2. Now, we already identified that 8G and 3G are like terms. So what do I do with my like terms? Add them. So what's 8 plus 3?
11.
Plus 11, what?
G.
And then what's my final
Plus 4.
area? And that's my final answer. So when I look at your papers, I should see this work, okay? This is what I should see on your papers. Now, if you don't want to write in your rectangles because the rectangles aren't big enough, you can still write them. Can I use your paper? You can write them out how Hannah did. She just wrote them underneath each box. That's fine too. But she still went ahead and put her final answer up to the right of her, where they're supposed to multiply the binomials together. Okay? Questions on example 3? Okay, let's go on to example 4. So example 4. Example 4 is a tad bit different in what way?
Just put a 1.
Okay, you can put a 1 in front of that H there. What else is a little bit different than this one, though? It has a negative number, so watch that negative sign, okay? So, what is my first group of numbers? What does my first group of numbers represent on my area model? What's this first group of numbers represent?
Or H.
The height, okay? So my first height is what? H. And what's my second height? What do I put? Right? 7. Good. My second group of numbers represents the... What's my second group of numbers represent here? Length. Okay, so what's my first length? And my second length. What do I do with this information? What do I do with this information? Of each rectangle. Basically, I'm distributing, but I'm just using the area model to find the area of each rectangle, and then I'm combining like terms. Okay? So let's just go around the room here. Danny, do the top left for me.
2H squared.
Okay, so you got area equals your height was H times 2H, and you got 2H squared. Good. All right. Ben, top right.
Top right,
Area equals what?
area equals 7 times negative 5.
Well, top right, bud.
Oh, okay, I got it mixed up. Area equals 1H
Times,
negative 5.
which equals?
Negative 5.
H.
H.
Okay. Bottom left. Hannah.
7 times 2H.
And what does that equal?
14H.
Nice. And bottom right, Logan.
7 times negative 5.
Good. You can use a little dot to show multiplication, but when I use a negative, I really don't like using the dot. So what's 7 times negative 5?
Negative 35.
Perfect. Okay, now I need to find the total area. How do I determine, how do I determine what the total area is?
Start with the highest.
highest, okay, which is
14.
the highest
It would be
power.
2H too.
Yeah, the highest power is what she's talking about.
Or to the
So-
second power.
2h to the second power. Then what? Do I have like terms that I can combine?
Yeah.
What are my like terms?
14.
Right? So what's 14h plus negative 5h, or negative 5h plus 14h? What's that equal?
9.
19? Whoa.
Say that again.
9.
9. Take negative 5 plus 14, and you'll get positive
Oh,
9h. And then my final term, so I did this,
35.
negative 35. Good. Thumbs up if you guys could do a worksheet on this now without any help. Thumbs in the middle if you probably need a little prompt, and thumbs down if you still think I'm speaking a foreign language. Okay. You guys all have it down? I know it kind of went fast that last time. Okay, flip it over. Oh. What do I do with this kind of problem? 2j plus 7 squared. What does that actually mean? 2j plus 7 squared.
Just cut. Invisible one?
What's that? Say it again?
Invisible one?
No, not invisible one. That's a good guess, though.
Um,
Well, what does to the second power mean? I'm going to take this binomial and multiply it by itself how many times? 2. So that would basically look like 2j plus 7. And if I multiply itself twice, I'm going to have to take 2j plus 7. Okay? So all this is this written like this. Okay? So to the second power just means I'm taking 2j plus 7 times itself twice. So there it is once, there it is twice. So basically I'm taking a binomial times a binomial. Okay?
So we don't keep the square.
You don't keep the square. The square drops out once we rewrite it. Okay? What's the height of my rectangles? So what's the height of my rectangles?
2j.
And
7.
and what's the length of it?
2j and 7.
Yeah. Okay. All right. So let's go ahead and find the area of each rectangle. I think we left off with, I think we're ready for Jenna, right? Is that right? Okay, Jenna, let's find the area of your have you do the whole top row.
You multiply 2j and 2j, that's 4j to the 7.
That's correct. Okay. And then I do,
Is it 2j times 7?
which equals,
14j.
okay. Maddie, let's have you do the bottom left, the whole bottom row.
The first one would be 7 2j,
Which equals,
14j,
and bottom right.
7 times 7 actually.
Equals,
9.
okay. When I combine these terms, when I add them together to find the total area, I'm going to first identify if I have any like terms. Do I have any like terms? What are they? Okay. I go ahead and just circle them like this so I don't forget about them. And then I'm going to write my final answer. You can write your final answer either here or you can go back up to the top here and write it. It does not matter. Okay. Okay, so I start with which term? The highest exponent, which is?
4j to the square.
Then what?
14j.
There's like terms there. We're going to combine that. 14j plus 14j, which is 28j. Then what? And there's your final answer. So if you guys would actually multiply or distribute this all out, you would end up with the same answer. Okay? What we're going to eventually do with this information, though, we're eventually going to take this here, and we're going to eventually factor it out to that. So we're going to flip the role that we're doing. Maddie's like, no, we're not, Miss Lidikin. No. Okay. Do y'all have this down? Yeah? Logan? Promise? Okay. Let's move on then. Example number 6. Go ahead and try to get example number 6 done on your own. Take 3 minutes to try to complete it on your own. Is that what you had so far? Have you guys gotten to a part where you're like, wait a minute? Okay. Okay, so walking around, you guys all have it set up great. It looked like you were finding your areas and you were doing a nice job of finding each individual area. But let's go ahead for the sake of time and go ahead and start finding the area. So we did 2k times 2k, which equals 4k squared, because I have 2k's. 2k times negative 5 is negative 10k. Then I took my height times my length, so 5 times 2k is 10k. And then my height times my length, which is 5 times negative 5, is negative 25. So that's the area of each individual rectangle. Now I want to find the total area, so I look for my like terms. My like terms were my negative 10k and k. I'm going to put them in order, so based on the highest power first, which is going to be 4k to the second. Then I'm going to combine my like terms. What's negative 10k plus 10k? 0. So do I need to put plus 0k?
No.
What would happen if I would put plus 0k? Would that actually mean 0 anymore? No, it would mean what?
0 over 1.
It'd mean 1, because anytime you put the variable k there, it means 1. So for this here, it basically just cancels out. So I don't write anything for that second term. What do I write for my final term then?
Well, a minus 1 black.
That's it. Okay. Okay, let's look at the next example. Now, for you artists,
I like to draw.
you know it. So example number 7. Draw a rectangular model to help distribute 3 times 2m plus 8. Now, when you go to draw your area model, what does this first number or group of numbers represent? What's this first number represent? Height. And what's the second group of numbers represent? Length. So how many heights are you going to have?
2,
How many heights are you going to have?
1,
How many lengths are you going to have?
2.
So you're going to have to draw an area model that would represent 1 height, 2 lengths. Yep. Maddie's got it. And it's not cheating to look back in your notes to see what the other area models looked like. Oh, girl, get rid of that.
What do you mean?
Because you have now 1 height here, but 2 heights here.
Oh, yes.
Hannah's got it. Danny's already halfway done. Ben, I think you have some competition. What do you think, Hannah? Okay, so what kind of area rectangle am I going to draw? So if I draw, you guys know my drawing abilities are not the best. Oh, here. So if I draw a rectangle, okay, look how great that rectangle is. When I draw this rectangle, if I want to have one height, am I going to divide my rectangle here? No, I'm going to leave it alone because I want one height. But if I want two lengths, what kind of line am I going to put in my rectangle? Am I going to put a vertical line in or a horizontal line in? A vertical line in. So that vertical line is going to separate my rectangle so that it has two lengths. Okay? So let's find the height. What's the height of my rectangle here?
3.
And my lengths?
2m plus e.
All right. Riley, find the area of the top left rectangle. Okay, so you did that by taking 3 times 2m and got 6m. Okay, top right, Maddie.
A equals 3 times 8, and I got 24.
Okay, and then your final answer is going to be what, you guys? What's the total area of this rectangle? What?
6m equal 6m plus 24.
There you go. Questions? Okay. Next example here. Draw a rectangular model to help distribute.